Mass and weight. Mass is the amount of matter present in the object. The SI unit of mass is kilogram. Mass is a scalar quantity. Its values is same everywhere. Its value does not change even when we go to another planet. According to Newton's first law, it is the measure of inertia of an object. Higher the mass, higher is the inertia. Whereas weight of the object is defined as the force with which earths attract the object. The force on the object of mass m is given by F equal to mg, mass into gravitational acceleration. Weight being a force, its SI unit is Newton. Force we know it's a vector quantity, it has a direction, and direction of gravitational force is always towards the center of the earth. As the value of g is not same everywhere, weight of an object changes from place to place. So if in the examination they ask you to differentiate between mass and weight, first point will be the definition, that is mass is amount of matter present in the object, whereas the weight is force with which earth attracts it, means it's the amount of force acting on the object. Second point is the unit of mass is kilogram, unit of weight is Newton. Then mass is a scalar quantity, whereas weight is a vector quantity. Finally, mass is same everywhere, whereas weight changes from place to place. So these four differences you can state. Colloquially, we use the terms mass and weight interchangeably on the surface of Earth, and the reason behind that, the gravitational acceleration on the surface of Earth is constant and it is 9.8 meter per second square. Value of g is 9.8 meter per second square and it is constant on the surface of Earth. But on other planets or on the moon, or if you go to height which is more than 1000 kilometers, then weight will not be same, weight will change. Will your weight remain constant as you go above Earth's surface? No, it will decrease. If the distance between you and center of Earth is 2r, then how much will be your weight? So this is the radius of Earth equal to r, and there is a ladder on which you are standing, and the height of that ladder is also r. That means your distance from center of Earth is 2r, then the gravitational acceleration capital G capital M upon 2r square, that is equal to gm, 2 square is 4, 4r square. So this g at height is equal to 1 by 4 g on the Earth's surface. So as the gravitational acceleration will become quarter, that is 1/4, your weight will also become 1/4 at that height. The weight of moon is nearly 1/6, weight on the moon is nearly 1/6 of the weight on the Earth. So if some object weighs, let us say 10 Newton on the moon, its weight on Earth will become 60 Newton. So, and this is because the gravitational acceleration of moon is 1/6 as the gravitational acceleration of Earth. So it is 1/6 into 9.8. So approximately it is, if you calculate, it will be 1.6 and something like that meter per second square. Gravitational waves Waves are created on the surface of water when we drop a stone into it. You have seen the waves created on the water surface. Similarly, you have seen the waves generated on a string when we shake its one end. Light is also a kind of wave, and we call that wave as electromagnetic wave. Gamma rays, which are means given out by the radioactive substances, X-rays, ultraviolet rays, infrared rays, microwaves, radio waves are all different type of electromagnetic waves. Astronomical objects emit these waves and we receive them using our instruments. All our knowledge about universe has been obtained through these waves. Gravitational waves are a very different kind of waves. They have been called the waves on the fabric of space-time. Einstein predicted their existence in 1916. These waves are very weak and it is very difficult to detect them. Scientists have constructed sensitive instruments, and one of such instruments is LIGO, that is Laser Interferometric Gravitational Wave Observatory. Exactly after 100 years of their prediction, in 2016, existence of gravitational waves was proved. Indian scientists have contributed significantly in this discovery. This discovery has opened a new path to obtain the information about the universe. Next topic is free fall. Take a small stone, hold it in your hand. So what are the forces acting on the stone? So if the stone is in your hand, then the gravitational force is acting in the downward direction, but your hand is providing a muscular force which is equal and opposite to the gravitational force, and that's why the stone is stationary, it doesn't fall down. But if you leave the stone, then it will fall with an acceleration small g, gravitational acceleration. Its speed will increase by 9.8 meter per second every second. So that is the gravitational acceleration. So such fall is called a free fall. So when the only force that acts on an object is gravitational force when it is falling, then such a fall is called free fall. Released stone is a free fall. In a free fall, the initial velocity of the object is 0, and then it goes on increasing due to acceleration due to gravity of the earth. During the free fall, there are some other forces acting on that stone, and the other forces are frictional force due to air and also the buoyant force applied by the air. These are the two different forces acting on the stone, and hence the fall of the stone in the air is not an ideal free fall. Ideal free fall can only be possible in vacuum. For a freely falling object, the velocity on reaching the earth and time taken for it can be calculated using Newton's equations of motion. For free fall, the initial velocity u is always 0 and the acceleration a is equal to acceleration due to gravity. Thus we can write the equation v equal to u plus at as, we have equation v is equal to u plus at and that can be written as, in this equation u is 0 and a is g, so v equal to gt. Again we have equation s is equal to ut plus 1 half at square. In this equation also u0 ag, so it is s equal to half gt square, and v square is equal to u square plus 2as u0 ag, so that equation is v square is equal to 2gs. The value of g is same for all objects at the given place on the earth. Thus, any two objects, irrespective of their masses and any other properties, when dropped from a same height, will reach the earth at the same time. This experiment was done by Galileo in 1590 in the Italian city of Pisa. He dropped two spheres of different masses from the leaning tower of Pisa to demonstrate that both the sphere reach the ground at the same time. But when we drop a feather and heavy stone simultaneously, we see that stone reaches the earth first and feather, it takes more time to fall. But that is because of the air friction and the buoyant force of air. If we drop the two objects simultaneously in vacuum, then they will reach earth exactly at the same